Welcome to our next lesson, which is going to be a quick one, but I think you will find it interesting. I want to share the complete picture when it comes to unit testing our DevHabit application. So behind the scenes, I introduced many more test cases, and I want to walk you through a couple of highlights. If you want to grab the latest source code, it's going to be available right under this video. Now let's jump into the code. If you open up the unit test project, you will see that there are a lot more test classes inside with many new test cases. All in all, I introduced 126 test cases. You can run all of them and they should succeed, granted that nothing significant has changed. And now let me walk you through the most interesting highlights of the things I introduced. For example, if I take a look at the create entry batch DTO validator tests, and you will also see this in the other validator test classes, I'm using some helper methods that the Fluent validation library exposes, which is the test validate or the test validate async method. This returns a test validation result, which comes with some extension methods that allow you to easily assert if you ran into some errors with testing your validators, and you can also check that you have an error for a specific validator test. So this is an improvement to what I showed you in the previous lesson. Now another highlight that's worth demonstrating is, for example, the GitHub Access Token Service tests. Here I introduced the EF Core in-memory provider, which I'm using to initialize the database context options, and this allows me to create a database context. With the encryption service, I can then pass this to the GitHub Access Token Service constructor, and now I have a valid instance that I can use to write my unit tests. So I can test the complete behavior of this type. Granted, it's only using the in-memory provider. Nonetheless, we can still test some interesting behavior when it comes to encrypting the access token, so you will find test cases for this inside of this test class. There's also a unit test class for the token provider, which allows us to get back the JSON web tokens and the refresh token. To validate a JSON web token, I can create a JSON web token security token handler, provide the respective token validation parameters, and then we have a validate token method. This allows us to get back a claims principal, and we can then make some assertions on this object instance. So this is another test class that I recommend that you explore if you want to learn more about unit testing. Another thing that might be interesting is the data shaping service tests. Here I'm using the approach where I created a private type, a test DTO, and I'm only using this type to test my data shaping service. I'm checking if the data shaping is working as expected, if the validation is also working as expected. For example, if we specify invalid fields, then the validate method should return false. And one last thing I want to demonstrate is the create entry import job DTO validator test class. I'm testing the respective validator here, but note that the DTO uses an iForm file. This is a type that's available in ASP.NET Core. However, we can create a mock instance. I'm using the nsubstitute library to create a mock of the iForm file, and I can configure what the respective properties on the iForm file instance should return. So for example, I'm setting the file name, the content type, and the length of this file, and I'm using these values to test my validation rules. So this is a good example of how to use mocking for your unit tests. And with this, I'm going to wrap up this quick lesson. If you want to explore the test cases, you are welcome to. We have more than 120 successful unit tests currently inside of our project. In our next lesson, we're going to talk about a more interesting testing approach. I'll show you how to implement integration testing for your REST APIs. We will use a real database inside of our tests, and I'll show you how we can send an API request to our REST APIs, execute our controller endpoints, and validate that we get back the correct result. Welcome to our next lesson, where we will implement integration testing for our REST API. I don't want to be too boring with this introduction, so let's jump straight into the code and I will show you how to write proper integration tests. In order to save us some time, I already created the integration testing project and I set it up with just the basic testing libraries that we will need. I also added a reference to the DevHabit API project, and this is configured to work with central package management. In the API project itself, I added an internals visible to for our new integration testing project, and now we can talk about what we want to do when it comes to integration testing. I'll start by installing two additional NuGet packages. The first one I want to look for is the Microsoft ASP.NET Core MVC testing package. What this library will allow you to do is to write functional tests, which are tests that call your API as external clients. The reason I'm calling this an integration test is because we're only going to focus on testing one component, or to be more specific, one use case in our system. We are going to integrate our system, the REST API, with any external components, which in our example is just a Postgres database. So let's go ahead and install the latest version of this library. And the second one that I want to install is Test Containers Postgres. Test Containers is an excellent testing library that allows you to spin up your external services as Docker containers inside of your tests so that you can access them to do proper integration testing. So I'm going to install the latest version of Test Containers Postgres, and now we are ready to set up some infrastructure components that we are going to need to write our integration tests. So let me go ahead and create a new folder. I will call it infrastructure. And inside of it, the first thing I want to do is to create a custom web application factory. I'll call this the DevHabit Web App Factory. And this type is going to inherit from the web application factory, which was added by the testing library. So let me specify the web application factory. Now this type expects a generic parameter, which should be the startup type of your API project. Now this is called the program file. However, we don't have a definition for this type. Or to be more specific, this type is internal by default and our web app factory is public. So the way to fix this is to go to your program file, scroll down to the bottom and create a public partial class called program, and now you'll be able to reference this from your web application factory. So you can see that the warning has disappeared and everything seems to be working. Now, what is the next thing we want to do? Well, I'm going to immediately start by defining the Postgres container, which is available in the Test Containers Postgres namespace. Let's give it the name of Postgres container, and this will be a proper database which we are going to connect to from our API project. But first, let's actually build the container instance. So what I need is a new PostgreSQL builder where I can specify a couple of arguments. For example, I can specify what is the image that I want to use. I'll use the same one from my program file. I can decide if I need a database to be created. Let's call it DevHabit. And for the username and password, I can specify some custom values, or I can decide to specify a default value. So I'll specify just Postgres and Postgres, and these are all the values that we defined inside of the Docker Compose YAML file. So here you can see our Postgres database, the user, and the password. So I'm just replicating this inside of our integration test. And finally, we can build this container. The next thing we need to do is to start it. And for this, we're going to implement the iAsync lifetime interface, which is an abstraction from XUnit, and it exposes two methods, initialize async and dispose async. Both of these are asynchronous, so let's mark them as async. And inside of the initialize async method, I want to say Postgres container start async. Conversely, in the dispose async method, I want to stop my container. So I will say await Postgres container stop async. So now I've taken care of starting and stopping my Postgres container. Now, because this type, the web application factory, already implements a dispose async method, you have to specify that this method is new so that the compiler lets you implement the iAsync lifetime interface. And now we need to connect our application with the Postgres instance running inside of our test container. So I'm going to override the configure webhost method, and here you get access to the webhost builder. Now, one of the things you can do is called the configure test services method. And here you can configure your application services, such as adding a database context, which allows you to override the database context definition and introduce another one that connects to the Postgres container. And I see this approach used so much, and I think it's simply wrong because you can achieve the same effect in a much simpler way. The webhost builder has a use setting method. This allows you to provide a configuration value with a specific key, and you can decide what the value should be. So what we want to do is to set the same configuration setting as the one that we are using to provide the database connection string. So this is connection strings and then database. So let's see how we can mimic this inside of our integration test setup. I need to say connection strings, and then I can specify a colon and the connection string name. And then I can access the Postgres container and call get connection string. And this is all that's required for the DevHabit API that will be running in memory using a web application factory to connect to the Postgres instance running inside of a container. There is no complicated setup required, removing services from the service collection, adding new definitions. Just set the configuration value and you're good to go. Now, one more thing we need is a base test class. So let me create a class that I will call an integration test fixture. And this is going to be a public and abstract type, and is going to implement the iClassFixture interface from XUnit, and here I can specify the DevHabit Web App Factory. What this will allow me to do is to inject a DevHabit Web App Factory instance. I can, for example, even do constructor injection to obtain the factory, and now I can use it inside of my code to implement some functionality. For example, I can return an HTTP client. Let's say I define a method called createClient, and I can use the factory to call the respective method and return an HTTP client instance inside of my test case. Now I want to comment on what are the implications of using an iClass fixture together with the web application factory. Using this approach, you will get one instance of your test container created for the test class. So this means if you have multiple test classes, then you'll end up creating multiple containers. This is something you should be aware of because it's eating up the resources on your system. And an alternative to this is defining a collection fixture where you can provide a collection here, and decorating your class with this attribute makes it part of the collection. Now, how do you define a collection? Well, you can just make a class, implement iCollectionFixture, define your type that you want to share between instances in this collection, and you can assign a name to the collection. I'll use the same one when specifying the collection attribute. So this is another alternative, and this means that you'll share the fixture data, which is our web application factory, between all test cases inside of the fixture. Now this is much more resource efficient because if you reuse this collection for all of your test cases, then you can only create one database container for all of your tests, and this will be much faster. Now this does have implications with concurrency and the fact that all of your tests will use the same tables in the database where you could run into some conflicts. So I'm just going to leave the collection fixture definition into its own file, and I'm going to comment this out, and I will be using the class fixture for my test cases. Now let's go ahead and define some tests. I'll create a tests folder inside of this project, and let's go ahead and create a test class that I will call authentication tests. So I want to quickly validate my authentication endpoints on the REST API. I'll implement my fixture base class, the integration test fixture, and I'm going to define my constructor. And now I can go ahead and use XUnit to define my first test case. So this is going to be an async test. Let's say register should succeed with valid parameter. Let's add the arrange, act, and assert steps. And then what do we want to do here? I first need a DTO instance. This is going to be the register user DTO. I need to set an email. I can use the same value for the name. And then for the password, I should specify something that's going to get past my validation rules. And I have to make sure that I use the same value in the confirm password field. Then we need an HTTP client instance, and we can use this by calling the create client method that we have on our base class. And we are ready to execute our test case. So I can say client post as JSON async. Then I need to specify the URI where I can access this endpoint. This is auth/register. I'm just specifying the relative component, and the base URI is taken care of in the web application factory setup. Then I can specify my DTO instance, and this should give me back an HTTP response message. Let's just name it response to make it simple, and we can go ahead and write our assertion. Let's say that I expect the HTTP status code of the response to be OK, and I can specify the response status code as what we want to assert. And now let's go ahead and run our first integration test. What should happen here is we start up the web application factory. This starts running the in-memory instance of the DevHabit REST API, and we can use the HTTP client to send a proper API request that's going to run through all of the middleware, is going to run through model binding inside of our REST API, is going to serialize the response before returning the response message back to the integration test. Let me go to the authentication controller, and I'll set a breakpoint in the register method. And now let's debug our one integration test, and you will see that when the test starts, we're going to land on the breakpoint in the register method. Now I'll add a breakpoint here before our assertion so that we can go back to the test, and you can see I'm going to execute my validator, start the transaction, and this is going to proceed to register a new user. Now I can press continue, and we'll get a response back inside of our test where we can see the status code. We can also parse the results of the content and confirm that it's a valid access token. So that's something that we could write in our next test. But what's important to highlight here is that we are testing the complete flow of an API request inside our application, from serializing the request DTO inside of our test to the request DTO reaching our API endpoint, going through all of the middleware and the entire request pipeline before coming back to us with an HTTP response message. And I think this is a really powerful way of how you can do integration testing for your REST